the actual Mars, and we did the actual terrain of Mars.
Yeah.
You could just walk around.
Yeah. Yeah, all of that terrain actually is publicly available. Okay.
All right, everyone. Thank you for coming today. We've got.
Do you want to see this? Sorry.
No, yeah, that's fine.
Okay.
Yeah, it's good.
We can just like.
No, it's fine. It's
Okay.
It's good. I can make sure I'm not slouching.
Thanks, Andrew. All right, everyone. Thanks for coming. And we have a guest speaker, Dylan Bennett, who's going to talk about Unity and how you can use it for augmented reality and virtual reality, and just going to open it up to the floor. So with that, I'll turn it over to Dylan.
Hello, everyone. So how many of you, just to gauge an idea of, I want to make sure I'm not, shooting a bunch of things either too low or too high. How many are familiar and, pretty proficient with C# by now? Okay, and then how many still more toward the beginning end of it? Okay, good. Intermediate? Okay, good. All right, so what I'll cover is I'll try to make sure that there's something interesting for everybody. One thing I'm going to cover is, which it sounds like some of you have some familiarity with Unity. How many have even used it ever, at least once? Okay. So I am going to cover just some of the real basics of, what Unity is and how to use it, and not like tutorial, but just to kind of give you your head around, this is how things work in it. And if you're coming in and you know something like C#, how would you even get started diving into something like Unity, and why would you want to use that, and that kind of thing? Does that make sense? Okay, and if you have any questions, I want you to feel completely free to interrupt and ask. I have no problem with you asking any questions. It does not even have to be related to what I'm talking about right at that moment in time. So some of these slides are going to be a little basic, but I'm going to go through them anyway. This is for Unity 101 talk that I've done in a couple different places. But it's just going to give you an introduction to it. But before I start on that, I'll tell you why I chose Unity and how I ended up getting into it. I knew C# from way back. I learned it when Microsoft first introduced C#, and I had been using, you're familiar with ASP.NET. So I had been using classic ASP, which is before .NET came out, and that was using all Visual Basic Script, which was Visual Basic Script. And then .NET came out, and they had C# as a new language, and all of this kind of stuff. I had been thinking about getting into Java at the time. C# seemed like a good transition because I already wanted to do the ASP stuff, and you could do it in Visual Basic, but I figured there's enough changes with the new Visual Basic that if I'm going to learn something, I might as well learn C#. So I learned C#, and that stuck with me for a long time. I ended up doing lots of projects in it, and all, like web projects and desktop projects and so forth. It was a lot of fun. But it had been a few years since I had been actively using it, and then I started wanting to get into game development. And I looked around, this is a few years ago, and I looked around to see what my options were. And I found options like Unreal Engine and Unity, and there's another one, Game Maker. They all looked really good. They all had strengths and weaknesses. Unity, however, used C#, and I already knew C#. So I was like, okay, well, I don't have to learn the programming side of it. Whereas Unreal uses C++, and while it wasn't foreign to me, I was not as proficient with C++ as I was with C#. Like with C#, I could just sit down and write something and have some kind of idea what I was doing. C++, I'd have to like get back into it. And GameMaker used its own language called GML, and I didn't really want to use a language that I was not going to be able to use anywhere else but in that program. So I decided to go with Unity. And the other reason I decided to go with Unity was because you can start from nothing and get to something very quickly in Unity. And that's what I found. I decided to just try it out. Let's see if I can make this one concept work. And I sat down, I had one concept I wanted to do, which was like a planet lander, like, driving around on a planet. And I was able to do that in like no time at all. And I was like, okay, I'm sold, because I have this idea, I know what I want it to look like, and in a very short amount of time, I actually had it working the way I wanted it to work, and it worked well. And I was like, great, that's it, I'm good. The other advantages it has is it can build for many different platforms. If you are building for Mac or PC or Linux or Xbox or mobile or web, it's like you can. There's a lot of talk about like write once, deploy everywhere. That was a big selling point of Java, which once you actually start doing development, you find out that's not always the case, and there's usually as much work goes into making it work on all these other different platforms as it is just to write the thing in the first place. But Unity does actually flatten that out quite a lot. I've made a number of small games, not like big ones, those do require some work, but I've made a number of small ones where I built it on my Windows machine. It worked fine. I told it, okay, build me a Mac version, and I handed it off to someone on a Mac, and they were able to use it with no problem, and I didn't even have to test it. I just was able to give it to them. That's not always the case. It was a smaller game, so there weren't a lot of edge cases where it would break. But it definitely is a lot easier in that environment to build for a lot of different things. I built a mobile game that you can play on your phone, and I built it on the desktop. And then it was only toward the end of the project that I just tested on my phone and made sure that it worked. I mean, obviously, I built it on my computer with the idea that I would be building it for my phone. But still, I was able to do most of the work just straight on the computer itself. Any questions on that? Or anybody else had like thoughts on questions about why they might want to use Unity they want answer to? I'm happy to answer any questions. So without any more, I will just get into showing you what Unity looks like and how it works. Unity is free, by the way. You can, excuse me, it costs money if you're making a lot of money or you're making a huge game. If you're making, I think it's over $100,000 a year, then it costs money for the Pro version of Unity. But if you're making over $100,000 a year, the Pro version is not a big expense for you, and it's likely that you would want to invest that kind of money in it. It does work kind of subscription-based the way Adobe works for their software, where you just pay, and then you get updates as long as you're paying, but once you stop, that's where you're at, And it has some other features for the Pro version. Really what the benefit is you get services available to you, like ad services and analytics about your games and that kind of thing. Also, when you create a game in the free version, it has a little splash screen, made with Unity. And when you have the Pro version, you can turn that off if you want to. The other thing is that if you have the Pro version, you can have a dark color scheme. Which to some people, that's a pretty big deal. So I'm going to start off and just show you, I have it loaded here. I'm going to load it with the default layout so you can see what it looks like when you fire it up. And what I'm going to do is I'm going to just walk you through, like, what are you looking at here? So let's say you download Unity and you want to get started. Right, well, what are you looking at? And that's what we'll go through here. So again, this is what it looks like when you first start out. Oops, I want to make sure I'm not.
They can see your screen.
Oh, that's right. Okay, good. I just want to make sure that I'm not backing out of the video. Okay, so down on the bottom, you have their project. And that's like all the physical files that make up your game. It could be sounds. It could be animation files. It could be, images for textures. It could be 3D models, anything. Any of the actual files that go with your project. They could be like the levels, the saved levels of your game. Hierarchy. What objects are in the scene? So when I say scene, I'm talking about like it's like a level basically. And what it is, it's like a 3D space that you can put stuff in and you can program how that stuff works. And it's totally up to you how that works. It could be 2D where you're looking at it only from the side. It could be 3D where you have a camera that's moving around, looking wherever you want. What the objects do is totally up to you. You could just have them sit there, and you could, move the camera around as like the player, walking through the level. But each thing in that space is a game object, and this lets you see how is all that structured. Like you might have like a car might have wheels as a sub game object, so to speak. So you can kind of see how the hierarchy of that. You can see, oh, the wheels are attached to the car, kind of thing. You get the idea? Then you have inspector. And this just, you can pick any object and it gives you all the information about that object. Where it is, how it's rotated, you know, how big it is, any extra functionality it has, like, you know, let's say you have that car object, right? It could be the script that lets you drive it. It could be the thing that adds the texture. It could be the things that tell like how things collide with that car. Like, is it a box? Is it like smooth? Is it how does the physics interact with it? So anything that is about that each game object, you can see over here, and you can change it too. The scene. This is like your, you know, architect's view of that space, that 3D space. And again, you can think of it like a level. Then you have another tab that is the game, which is what do the players see. So this is what you as the game designer would see, and it's the scene tab. And it's hard to see because of the overlay, but I'll show you in the thing. It's just a little tab over there. And so you have, this is like you're as the game designer. This is, okay, what does the player see? And so that's like the interface. So again, this is what it looks like. The cool thing about Unity is that as you're building it here, right up here is a play button. And when you click play, your game starts right there in this window. Remember I said this is what the player sees. So if I hit play, there you go. The game is running right now. Now there's nothing in my game, nothing at all. So this is it. But my game is running right this second. Which is really nice. It's really nice to be able to like have that ability to just like start your game immediately and just run it right there. And you can adjust how this looks. Like if you decide, oh, I want this to be like, you know, 1920 by 1080 type game, you know, like a widescreen game, then when you can say that, oh, pretend the screen is, you know, like a widescreen. So then I'm going to explain, I'm going to show you how easy it is to add something here. So notice I don't have any files that are part of my game yet. But if I save this scene, this space, I'll just call it level 1. Now we have a file. That's a physical file that represents the saved 3D space I have. And then now you can see it up here. This is an actual, you know, the start of this list of objects. So let's say we create an object. I'll create a plane. And there it just sticks a plane right out in the middle. And I have an object over here called plane. Now you notice no files showed up because this is just a game object. It's not like a physical file that I'm using to create that. Over here, I talked about the inspector, which is where you can see all the things about it. So you can see its position, its rotation, its scale, and you can pick any of these numbers and change them. So if I like, for instance, if I change the X rotation, I can just grab it and drag back and forth, and you can see what happens to the object. And I can also change the position. I can grab that number and drag it up and down. I can also just grab it, you know, right here in the scene. I can mess with it this way. Then there's, and then I'll go into what you're looking at here and how to, like, what you actually see. But I'm going to explain first a little bit about how Unity structures this 3D space. So when you've been learning C#, have you learned about, you know, classes and objects, you know, and instances of a class, you know, those are the objects. So going back to this, in a lot of games, this is the traditional way that you would create the structure of your game. You would have like a vehicle class, and then from the vehicle class you'd have like a car class that would inherit from vehicle. So a car is a type of vehicle, wagon is a type of vehicle, so anything related to vehicles would go in the vehicle class, and then anything specific about a car would go in the car class, right? And then character, you know, you might have an overarching character class, and then from that you have like a player inherits from that, and then NPCs, which are non-player characters, those inherit from the character. You get the idea. Like, it's very structured in terms of how you organize, like, what gets its abilities from what. This becomes really tough because then what if you have, a grenade launcher where, okay, what it's shooting is a grenade, but it shoots out like a bullet, and up until it explodes or hits something, it's a bullet, but then it turns into a grenade. Like, so what does it inherit from? Does it inherit from bullet, or does it inherit from, like, or do you have like a really finicky projectile? Like, it gets really confusing on these huge games like Halo and stuff like that. So Unity takes a different approach, which is, and this makes sense from like an object-oriented, way of thinking. And so it's not a bad way to do it. It's just, it can get complex when you have a really big game going. So what Unity does is they do this, it's called component-based. And each component is its own script. And the scripts are just kind of like a nugget of functionality that you're going to add to this object. The object starts out just having a position, a rotation, and a scale. It usually has nothing else added to it. And then you can add stuff onto it. Like, for example, and these scripts, they do only one thing. And you try to make it so that you can use that little nugget of functionality on other things. And you try not to hard code in what it does. Like, if you wrote a script to make something be able to move, you don't hard code in like how fast it moves. You make that a variable that you can change. And how that ends up working with the game objects is, so here's, you have a mushroom, a coin, and a star. So you'd have a component, a script, that makes it pick upable. And so you write some code that allows it to see, has the player hit me? And if so, pick me up and make me go away, right? So the coin, the star, the mushroom, they're all pick upable. They wouldn't, in an object-oriented, traditional object-oriented style, they wouldn't like inherit from the same thing. I mean, maybe they could from, a pickup class, right? But then you'd have to have things like moving and spinning and bouncing, how would you build that in? So what you do is you write a component, you write one for pick upable, one for something that moves so that like it actually pays attention to where, the ground is and it moves back and forth. Or like for the coins, make it spin, so it just sits there, and that's all it does is just, that one script, all it does is just tell the thing to spin. It doesn't do anything else. So for the star, that also would have a move. Notice that the coin does not have move, but the star would also have bounce. The mushroom doesn't have that. When it falls down, it just hits the ground and keeps moving. Whereas a star, when it hits the ground, it bounces, So this approach allows you to take these same pieces of functionality and you just stick them on to what needs it. So like in that example of the, grenade launcher that acts like a bullet, and you could just, add whatever functionality you need to make that particular thing work the way you want it to work. And a lot of these scripts can be shared. Like I have this script for spinning. I could put that on anything I need to spin. It could be, you could put it on a car. You could put it on, maybe there's a thing where when the player gets hit, he spins for, a certain amount of time. Okay, fine. But the things that you don't hard code into that are how fast to spin, what direction to spin, that kind of thing. That's all settings you can do when you add the script. Here's another example just for more clarity. Like here's, okay, different enemies. They all can move. And they all have a script that says if the player touches it, damage the player. And they might have a variable of how much to damage the player. And then some of them have a script that's like makes it squishable. So that means if the player hits it from the top, it squishes. Or jumps so that if it moves along, it jumps. Pick upable, meaning after you hit it, you can pick it up, just like you could pick up something else. The bombs are also pick upable, but they don't jump, but they do explode. So there's a script in there that makes them explode. You get the idea, like you can see where there's these similarities between these things, but there's also these differences. And it's very easy to just take these nuggets of functionality, these components, and just add them on. So examples of different game objects that you would have is players, coins, level geometry, like doors and walls and things like that. UI elements, like your health bar, or maybe you know, the number of coins you picked up, or the name of the level, or whatever, you know, is in the user interface. The game manager, which that might be an object where it's not visible in the game, but it's there to like manage, you know, keep track of the score and, you know, check to see did they win the level yet, or, you know, things like that. Might just be doing like, you know, management of the game. The left hand of the enemy, that is a game object, you know. Empty placeholder objects. Maybe you just need like a empty thing sitting there so that you can, you know if the player reaches a point. The player doesn't see it. They don't know that it's there, but it's just sitting there in the game. Does that make sense so far? Any questions? Okay. So just to show you in here, so you can see over here, these pieces are these things separated out by these lines here. Those are the components. Those are the scripts being added to just this plane. You have, I'm going to go over what these are now, but every game object has this one. It's called a transform. Okay, and I'm going to explain what that is. So the transform, to transform something, means to change something about it. And when we're talking about computer graphics and games and stuff like that, we're talking specifically about moving, rotating, or scaling something. The noun is the things about an object that you can change. So the position, the rotation, and the scale. So the transform of an object is what those things are. Like, where is it? How is it turned? How big is it? Right? So those collectively together are called the transform of that object. Does that make sense? Okay, good. So in Unity, it looks like this. You have a position, a rotation, and a scale. And you have it on X, Y, and Z. So those are like the three axes. So you have X going this way, Y going up and down, and Z going in and out of your scene. Okay? So where is it on those? You know, 0, 0, 0 being the center of your world. Where is it? And then you can think of like how, if you were to turn it on these, you know, how is it turned? And then the scale, which is like how big, sizing this way, this way, this way. So you have where is the object, how is it rotated, how big is it? And these sets of three numbers are called a vector 3. Vector is just like a set of three numbers, or like, and it can be and describe a position in this case, or just it can just be a way to hold those three numbers together. Does that make sense?
Yeah.
So if we go back here into Unity, you'll see this plane has a transform. It says that it's minus 1.17 units in the X, 0.87 units in the Y, and if I change, you know, this on the Y, that number goes up and down. Z, now my camera is like not oriented the way the player is, but like if I go into the game and I move my plane down, you see how it moves down? And if I move the Z, I can make it farther away from the camera or closer to the camera. X goes back and forth. You see how that works? But this has a transform. If I go in here and I create an empty game object, just nothing in it, there's nothing in this game object. It sits here, all it has is a transform. There's nothing else to it. The plane has other things to it, like it has what's called a mesh, which is like, what are all the polygons of this plane? What defines, you know, what the polygons that make up this. Then I have the mesh collider. This defines how does physics interact with this? And the collider is basically saying that, like, here's how things can collide with this plane. And it's a flat collider, so things, when they come from the top, will hit it. The mesh renderer. So this says, how do you show those polygons to the user? The polygons could be there, but then you could have the game not draw them, right? This might be handy if you have a game, you know, object that you don't want the player to see until they get to a certain point. Well, you can just not draw it until they get there. You can leave it in your game. It's not gone. It's just you're not drawing it. And then the renderer tells it to draw it. So if I turn that off, you'll see the polygons are still there. You know, it's showing that there's polygons there. You don't actually see them. But in the game, we don't see the plane anymore. But if we turn this back on, now it's going to draw the polygons. There it is. But this is what I was saying about, like, this thing's only job is to draw the polygons. It doesn't do anything else. It has nothing to do with the physics. It has nothing to do with what the polygons are. It just draws whatever polygons there are. Does it make sense? Like, that's how contained that unit of functionality is. And it has things like, you know, what color to make it and so forth. So I can, you know, if I want to, I can mess with the color and change it. So remember I talked about a vector 3. A vector 3 is it's just a way to store 3 numbers. And those 3 numbers could represent all sorts of stuff. A position, it could be a direction, it could be, you know, how it's rotated, whatever. So here's how it all fits together. How many of you use Visual Studio for doing the C# stuff? Okay. So you know how Visual Studio, you have a solution, and then there's projects, and then there's like your code files. Similar kind of structure. You have a project which holds all the things of your game. Your project is all the files, all the scenes, all the, you know, everything that's part of your game. All the settings, you know, like how does this, you know, when you want to build it for an Xbox, what are the settings it uses? The project holds all of that. In the project, there is multiple scenes, okay? And these scenes are like your levels. And then each scene is made up of a bunch of game objects, okay? And then each game object is then made up of all these individual components of functionality. Does that make sense? And this is how Unity builds its games. So if you're going to go from one level to the next, you're just telling it, okay, load this next scene over here. And that scene will have its own set of game objects, and those game objects will have their own, you know, pieces of functionality. Does that make sense? Okay, good. So I'm going to give you a quick demo here, so just so it's not all just taking in data. You can actually see something. And I want to show you one of the strengths of Unity, which is, so we just stuck a plane on here, right? And I'm going to rotate around here so I can look at it the same way that the player's looking at it. I'm also going to change you can rearrange how all these are too. So like this is how I like to do it, is I like to have it where my inspector's over here and my list of, you know, files and game objects over here, and then I have this space over here to work on my scene. You can also split it too, so like maybe you have the game down here, and so this is what the player sees down here, but this is what I see over here. So in this example, so we're going to add a sphere to our game. I'm just going to say, so we already have the plane added, and I'm going to add a 3D object, a sphere here, and there's the sphere. Now when I hit play, also I'm going to make it maximize when I hit play. That way you can see much bigger what's happening. You can see nothing happens when I hit play. I just put a sphere there. This sphere has no functionality other than draw itself. That's it. Unity has a whole physics engine built in, so you don't have to program the physics. Programming physics is a pain in the butt. There's so many things you have to keep track of. And it's hard to do it efficiently. Even if you did have to do it yourself, there's so many edge cases that would be really frustrating. There are some game engines where you have to program all the physics. But usually a good game engine has the ability to have all that stuff do it for you. So in this case, on my sphere, I can do things like I can add this physics component. It's called a rigid body, which basically says, this is a solid object in the game. This has physics. So if I add that, now it lets I just added that component down there, and I just added that piece of functionality that says you now have physics. What that means is that I have things like mass and drag, so like when it's moving, how does, you know, it get slowed down? Should gravity apply to this object? All these kind of things. Now if I hit play, I'm going to pause it first so I can unpause it when I need it. Now when I unpause the game here, see what happened to the ball? I'm going to unplay and I'll replay that again so you can see it. So hit play, and the ball falls, because now it has gravity, and now it's a physical object. You notice it doesn't bounce though, because I haven't told it to bounce. I haven't told it that it has the ability to bounce. I haven't told it that, like, one of the physical properties of something is how much bounce it has. Like if I dropped a ball of lead, it would probably do the same thing as that ball, right? But if I dropped a rubber ball, it would bounce. So I can do things. I can add a file here that says I want something that has like physical properties, like how much bounciness, and we'll set the bounciness to 1. And now when I look at my sphere, I can drag in this bounce. I can call this material bouncy. It's like a physics material. Kind of like I could even call this rubber. So if I want things to act like rubber, now I have rubber. And so I can take this sphere and I can say, you know what? The collider on this the collider should act like rubber. So I add my rubber in there, and now when I hit play, now it has some bounce. Not a lot of bounce. I could make the bounce more. Up the bounce. Now here's one thing cool about Unity is that when you are running the game, I'm going to run it down here in the window here. Let's make it bigger. I can adjust things while it's playing. Like I can move it up while it's playing. I could type in a number here and say, make this 10. And then I can also go here to my rubber and I could say, you know what, make this 5. Or I can't go higher than that. It looks like, oh, I could take the friction off. Now there's no friction. The floor is not bouncy either, and that's also part of the problem. Let's go to the floor and add rubber to the floor. And now let's drop the ball. And we gave it perfect bounciness. So the floor and the ball are bouncing against each other. And it's that easy to add physics to it. If I go to my rubber here and I make it slightly less bouncy. Yeah, I also took off the friction. You can see. So, but you get the idea. You can mess with the settings here. Now I want you to notice something. When I hit play, notice how everything went back to how it was. Like if I stop hitting play, it goes, and resets itself. That's actually a useful feature because you can then mess with things while it's playing, and when you're done playing, it resets it back. That can also be a problem too because let's say you're trying to tweak something so it works just right, and you do it while it's playing, and then you stop playing, and now you just lost all that. So you have to. That's why it's a setting. You saw how my thing turns green. It doesn't do that by default. By default, it just starts playing. But I added the setting. I want it green when I'm playing because I want to absolutely know that anything I change in here is going to not be there after I stop playing. But I want to show you something important here, which is one of the real strengths of Unity. So what I did is there's a thing called assets. Assets are just bundles of scripts, models, anything. They're just things that go with your game. And Unity has a really great way to bundle up assets together, whether it's just scripts for, helping you program, whether it's 3D models, and you can import them into your game. And they do tons of different things. You can import an asset that's like a whole sci-fi cityscape. You can import an asset that's just like the models for a tavern. You can import an asset that is how to make how to make something like have a certain kind of physics. You could import something that keeps track of inventory for a player. You can get as big, small or complex as you want with these assets. One of the assets that I imported that comes with Unity is called characters, and what it is it's a whole set, and you can actually see when I go to import it, it's wave files, which is like audio files, it's C# files, it's 3D models, it's a whole collection of stuff. But one of the things that it does is it makes it so I can add a lot of functionality just like that to my game. So this game is cool, but it's not very interactive. So I'm importing this asset called characters. And it's a package of assets that allows me to add a lot of different functionality to my game. I'll show you in a sec. It takes a sec to load it in. Also, this is not the super fastest laptop. It's a few years old now. And it only has to import these once. So now, you see in my files here, I have a ton of these files. And these are files. My game hasn't changed. But in here, I can go to characters, first-person character, like a first-person, type game. Prefabs, which are like pre-built game objects. They're actually stored as files so that you can use them again and again. Like you might make an enemy as like a prefab, which is, you've created the enemy and now you set it as a file so that you can use it however many times you want. And I'm going to drag in an FPS controller, which is a first-person shooter controller. And I drag it in here. I'll move it up a bit. And if we look at this, you can see it's like a capsule with this circle around it. And you can see it has this camera icon here. That's because that's like the player's viewpoint. Watch what happens when I hit play now. You see it? You can hear the footsteps too. I can jump. Do you notice I hit the ball? Rolled off. Like instantly, we've just completely changed what type of game this is. This might have been like a point-and-click game where you're like doing something and the objects do whatever. Now it's a first-person game, just by adding that one thing. You notice I haven't written any code yet, but I added the ability to make this a first-person game. If I want to, I can add in other things like, let's add in a box or a cube. And remember I talked about it has position, rotation, and scale. So I can adjust that just by, dragging these, and I can click over here and change things like the scale of it, like make it bigger, or I can make it bigger in one direction or another. And this is now in my game. When I hit play, here's that thing I just added. Right? And when I try to walk into it, I can't. It stops me. That's because it comes, when you make a new box, it has that collider component that says this is how things with physics should collide. It's very easy for me to click on that cube and say, I don't want a collider. Just uncheck it and say, nope, I don't want that collider to work right now. And now, when I run it, there's no script in that box that's going to stop me from walking right through the box. Oh, I hit the ball again. So you get the idea? So now I'll show you like what it looks like to add some kind of programming to this, because it's really not hard. I'm going to take the first-person controller and I'm going to deactivate it so that now we're back to just our pretty standard, here's this thing. So what I'm going to do is I'm going to add a script. I'm going to write my own script to change the color of this box when I click on it. So I'm just going to go here to my files. I'm going to create a new C# script, and we're going to say change color on click is what I'm going to call it. And it sounds a bit verbose, but I want it to be clear that this is what this script does. So when I drag this onto something, it's now easy to have that do just that, change color on click. Is it loading? Let's see. I think it's loading. There we go. I'm going to move my sphere here. Sorry, it's still loading Visual Studio in the background. I'm going to move this too so that we switch my viewpoint. So we're seeing more what the player's seeing. So one thing I want you to see is that right now the renderer is that component that has all the information about drawing this to the screen, right? So if I want to change something about the color of it, I have to talk to that component. And so in the script, what I can do is I can just make a function. So this script starts off, it's a class called a monobehavior, which is basically just it's a base class that Unity creates for you that has all the things that you need to mess with a game object. you have immediate access to where it is, its position, rotation, and scale. You can, get access to any of the other pieces of functionality that are added to it. So what I'm going to do is I'm going to add a function called onMouseDown, which means that when the player clicks their mouse down on this object, I'm going to, what I want to do is I want to get the component, the renderer. That's the component that draws it to the screen. I'm going to get that component, and I'm going to change the color of the material. The material is like the thing that tells it what texture or color to use. Okay. I'm going to say the color should equal. Now, I could set the color directly in here. Like, I could write in, like, I want it to turn blue. So I could just say color.blue. Oops, I meant blue. There we go. So we have color.blue. So what this does is I've written a script where all this script does, actually I'll take this out because I don't need those. It gives you some default functions to add some functionality, but we don't need them. So this is all this script does. If you click it, it changes the color to blue. Now, when I go back to Unity here, I can drag this script, change color on click. I can drag it onto my cube. And now you can see down here, that component is now added to the thing. And when I play this game and I click on the thing, it doesn't work, of course, because that's how things go like this. Let me just make sure I'm doing the right thing here. Oh, set color. Oh, wait, nope. I should be able to do color, sorry. Normally this works right off and it's never a problem, so I'm trying to figure out why.
So the name of your method there automatically picks up the event?
Yeah, it should. I'm not sure why it's not.
It's because we're watching.
It is. Usually 9 times out of 10, that's actually what's wrong.
And everybody close your eyes.
Yeah, everybody close your eyes.
Don't want to type.
I'm probably just getting the wrong property here is my guess. So I'm just looking through here and just making sure I'm getting the right thing. Well, that's annoying. I'm not sure what's going on there. Well, this is a bad demo. I'm sorry. So here's an example of where you can make use of something where you can debug stuff, where I can have it write to a log what it thinks the color is. So let's try it and see. That's the problem. It's not picking up the mouse clicking on the object. So I think I might have the wrong function here. Let's check it. Nope, it is the right one on mouse down. So we're going to do this. We're going to do this another way because I'm not sure what's happening there, and I apologize. We're just going to make it so that if they press a button, it's going to do that. How's that? So if it detects input from a key being pressed, and that key is, we'll say C for color, then it should get the color and set it to blue. Probably something where I'll go watch this later and be like, why was I doing that? Alright, let's try this. Okay, so we hit C, it turns blue. Sorry, I'm not sure why the mouse wasn't working on that one. But the problem is here is that I've coded this, hard-coded it to say this should be blue. But let's say I want to change color to the sphere. Well, I don't want the sphere to turn blue, I want the sphere to turn another color. But I added the same script to the sphere, so now they do exactly the same thing. So you can make this more flexible by adding a variable in this script, a public variable of type color, and we'll call it, we'll just call it color. Now instead of setting it to color blue, we set it to color, this public variable that I made. What that means though is that now when we look at the component, it has a space here waiting to see waiting for us to set that color. And I'm clicked on the cube right now, the wall, so it's set to one thing. So I'll set it to red. But now if we click over to the sphere has its own color set. And we'll set that, say, to a green. These are set, even though the script is the same, it's set individually to each object. And that allows you to have differences in these and how they act, even though it's the same code. So now we run it, we hit C, and now they each turn the right color. Adding this kind of coding to your game is very simple. And that's like the absolute simplest, most basic thing. But you can add any kind of thing that you want. Like, for example, we could say, so this function here that it's running is update, happens every time it draws to the screen. So this is gonna run this code every single time it draws to the screen. We could add whatever we want here. Like we could say, if they press a button, then change the x coordinate. So you can make it so that if they're pressing like W, okay, make the thing move this way. Or if they're pressing A, make it move this way. You get the idea? Like you can code it to however you want. You can make it respond to a game controller just as easily. And adding this types of functionality to the objects in your game, that's the strength of Unity, is that you can just write these small individual units of code that do quite a lot.
So you can stack basically functionality
Yep.
on top of each individual thing. So you could build a base class for a specific function,
Yeah.
and then add it to the different elements. What about it with the idea where you have things replicating on an ongoing basis, like where we instantiate
Sure.
an object, and how do you do that so that every time an object is created, it's going to have that functionality, having to put it on every single object?
So let's do that. Let's make an object called spawner. We'll call this a spawner. And we're going to stick it right up here. And what we're going to do is we're going to create a sphere. And we are going to make a material here that's certain color, just so that we'll call it maroon. So that's a nice fancy color. And we're going to drag this color onto the sphere. So now we have a maroon sphere. And we're going to add physics to this sphere. And we're going to tell this sphere to be rubber. So it's going to bounce. And so we have this sphere that we've created. And we're going to call this sphere, we're going to call it ball. Now what I'm going to do is I'm going to drag it into my files. Out of the game scene into my files. And what that does is that creates an object, a file, based on that object. And now that's like a saved template for a sphere. And I can delete it out of here, and it's still in my files. Now what it means is that in our spawner, we can add a script here. We'll just call the script spawner. And this spawner, every time the game updates, it's going to listen, and it's going to say, if they press, sometimes this happens and it's really annoying. It's like I can't tell if it's Visual Studio or Unity, where the autocomplete won't update. So, we're going to say if they press the button, or let's say they press the fire button. The nice thing about this is that this fire button could be from a game controller, it could be from the keyboard, it could be from anything. It's generic, and you can just say if they press the fire button, and then the fire button can be set to whatever key you want. If they press the fire button, we're going to instantiate, and then you just tell it what prefab, what already created object. In this case, we're going to call it ball. And where do you want it to instantiate it? Well, we can instantiate it right here at the spawner. So we can say at this spawner's transform position, and we're going to give it a default rotation, and that's it. Now, I just say, do ball, but it doesn't know what ball is. So what I have to do is I have to go up here and make that variable up here that says we want a default game object called ball, but we're going to make this public. Now, when we add our spawner script to our spawner, now remember our spawner is just this object here. It doesn't have anything to it. It doesn't have a, polygons or anything. It just has the script. But notice it has an opening here for a ball game object. It's that variable. So we can just drag our ball in there. And now,
How does it know what the fire one button is?
that is because there's a setting in here that's by default that defaults fire 1 to the left mouse button, and it defaults fire 1 to pressing the joystick button, and it defaults fire 1 to left control. So by default, left control is already set to that. So if we click, now why is it doing so many of those? Because the update is happening every frame per second. That update function happens. So if I hold down. So every update, it's adding a ball. Now, the ball has physics. What happens if two things are in the same physical space? It pops them apart. So we have a problem. These are the best kind of bugs.
That's a great problem for a 10-year-old.
Totally. Now here's the thing. This could turn into a game mechanic very easily. But what we want to do is we can go in here and say, instead of get button, we can just say get button down. And then it'll only look for when we press it down. So now only when we click.
Wow, they're perfectly balanced.
They're perfectly balanced because we're not giving them any But here's the thing. So it doesn't have to be, the ball doesn't have to show up at that spot. That spot could be anywhere. I could say, pick a random spot inside, this area, right? Or pick a random spot out of these locations. Like I could give it a list of locations, just have it pick a random spot. Yeah.
You could basically create a mini section of a ladder, push a special button and have it build a ladder to go to the next level.
You could.
Just and walk up the ladder, go to the ladder, go to the next one, and build your own ladder up again.
You could.
Is there a reason why it's not complete physics, whether or not falling?
Because it's perfectly aligned. If we even put it off just a tiny bit, it would start to, fall apart. Now, I'll show you an example. Like you could say,
We haven't had it with yet.
Yeah, I was gonna say it's perfect inside of that computer.
there is a, I think it's, I can't remember what, there's a thing you can do where you can tell it to pick like a random position inside of a sphere, like inside of a spherical volume. And so you could have it like make a very small one where it's just barely offset. Yeah.
When you first started,
Yes.
no objects in there, there was still some scene
Yeah.
features like the sun.
Yeah. Oh, those were game objects too. It does actually include those by default. Yeah, no, that's a very good question. I forgot to point that out. It starts off with a camera, which is over here. And you can see what it's looking at here. It does start off with a camera, and it does start off with a light source. That's a directional light source, meaning it doesn't matter where it is, it's always going to shine in this direction. And you can rotate that, like I can,
Oh, wow.
So, now when we play it, so yeah, that was a good question. Anyway, so this is super simple. This is like a really dead simple scene. Now, we talked about doing like VR and AR. One of the reasons to use Unity is that it's so simple to get started with VR and AR using Unity. In fact, it's all built into it. So if you have a virtual reality headset like Oculus Rift or HTC Vive, and you have that plugged in, it will automatically recognize it and use it. But your game has to know to be able to use those things. And the way that you do that is under the project settings, there's a checkbox here. Virtual reality supported. If you click virtual reality supported, this now works for virtual reality. And like if we turn this FPS controller back on, which is the thing that allows us to like walk around our level. If we had a headset plugged in, if I move the headset, this camera would move too. And that's how easy it is to get stuff up and running for VR in Unity. Let's say you have one at home just for playing around, like I do, and you have it plugged into the computer with Unity, and you have that checkbox turned on, and you hit play in your game, and you put your headset on, you will be inside your game, like that fast, which is really cool. Yeah, see if I hit the control, I went to hit Control P, and it starts adding balls. You notice when I bonk into it, they all come falling down, and they roll right through this because we turned off the collider. See if we can get another stack going. All right, let's see. Yay! We already have a fun game going. Look at that. Good question. So, let's say we have this and we want to put it out there so someone else can play it. You go to File, Build Settings, and then you choose what platform you want to publish to. PC, Mac, Linux, WebGL, which means like loading on a web page without any plugins. And I stress that, without any plugins. Like you don't have to have Flash. You have to have Flash installed. With the older version of Unity games for the web, you had to have like a Unity plugin installed on your computer. This is just a batch of JavaScript that runs in a web page. So it runs as a straight HTML5 thing. So we can do that. I don't want to do it here for the demo because it actually takes a long time for it to build it. iOS, Android, Xbox One, PS Vita, PS4, Facebook game. So I'm going to build it for PC. You can pick whether you want it to be a 32-bit or 64-bit app. I can choose Mac OS or Linux. We're going to do Windows. And player settings allows you to check things like what resolution do you want it to play at by default, all sorts of stuff. So we're just going to leave all that by default. you can set the icon that the game uses, all that kind of stuff. So we're going to just say build, and I'm going to make a folder here called builds. And we'll call this awesome sauce. It's going to take our game. It's going to make sure, oh, we have to, hold on one sec. I realized we have to add this scene to what we want it to build. We're going to build it. There we go. Doesn't take a whole long time to build, especially if the game is small. If it's larger, it can take more time.
What about time?
What about time?
How would you include it in the game?
Oh, you can just use standard, C# time controls like date, time, now, and things like that.
And you can make that lighting change as well.
Yeah, absolutely. Yeah, and so it keeps track every time it updates to the next frame. Like you saw, remember, it's keeping track. It's running that function like every time it draws to the screen. It actually, every time, it keeps track of how long was it since the last time I drew to the screen in milliseconds. So if you want to keep track of it, like let's say you want time to be accelerated, you could actually say like after 5 seconds do this. That's very, very easy to do. So here, I have an exe file ready to run. I can double click it and run it at 1920 by 1080 at ultra quality settings. Notice this is with a free version, so it says made with Unity. And here's my game. This is exactly as we built. If I click, it runs exactly like it ran in the player.
Is there a roof to the sky?
Yes, you know the integer limits of numbers?
So, 2 billion and change?
Yeah, so this is actually something that some games have run into. How many of you ever heard of Kerbal Space Program? So it's a fantastic game that simulates a space program. And you can build rockets and fly them and, you put them together, you get a budget, and you have to, you get these little people called Kerbals that you have to go, that are very brave by flying in your completely half-built broken rockets, and you can, your goal is to fly to the moon, and yeah, the moon, and
It's a tough game.
it's a tough game. I mean, you're actually like you should see like kids who have played this game, they have like this fundamental like innate understanding of orbital dynamics that you often don't get until you're like literally a rocket scientist, and it's cool because like people from NASA who have interacted with kids who have played this are like, these guys know what they're doing. Like they like know like how orbital mechanics work. I mean, it is as physically close to a space program simulator as you can get, including having budgets. And and what they do though is like you're actually like the pieces of all your rockets and everything are actually physically put together. So if you're hitting a bunch of turbulence, they're like shaking apart and stuff like that. And, it's got like air turbulence as you're coming down and all this kind of stuff. It's really cool. You should see some of the things that people have done with this. It's unbelievable. Some people, and they give you all the instrument data about how it's working. There are some people that go so far as to, they just fly by the instrument data alone to try to fly their, simulations. Here's the thing though, when you're trying to deal with, going to the moon, literally that type of distance, in orbital mechanics, you have to deal with some pretty big numbers. And you have to deal with some really small numbers, like the pieces fitting together in the rocket, right? So you get really small numbers and really big numbers, and computers are not great at dealing with that wide of a range. Either you're dealing with really big numbers and it does great, or you're dealing with really small numbers and it does great. How many of you have heard of the problems with floating point numbers? Okay, so floating point numbers are not very exact. It's kind of a fuzzy math that happens, okay? And, if you tell it, like, if you take, a third plus a third plus a third, you don't get 1, you get like 0.9999999, right? And there's other, things where you'd expect, 1 plus 2 to equal 2, or 1 plus 2 to equal 3, and it actually is 3.0001, you know what I mean? Things like that. That's not a big deal for most of the time. But when you deal with really big numbers, and you're dealing with this like little pieces of a rocket that are like literally millions and billions of units away from your planet, okay, well now it's a problem, because like a 0.01 off means one part of your rocket is like over here. And so what would happen is people would build these rockets and they'd go flying off into the solar system and they'd go, and then they would like rip apart and like have all these problems. And so they ran into that problem where, you know, as the numbers got really big, physics didn't work anymore. So they actually had to rewrite some of the source code of Unity to make it work, make the physics work even when they're like way off, and they did some really clever stuff to make that work. But you know, that was a very extreme case. I don't know if you've ever seen the videos like when you get to the edge of Minecraft. Like, you know, Minecraft seems like it goes on forever, but you can't, if you actually go far enough, you get to the number limits of the variables that are storing the positions and the procedural generation, like how it generates the terrain. And the terrain just gets really weird. You get like sheer cliff walls with like bizarre holes in them and stuff like that because all the numbers get broken. Anyway, so that's how easy it is to build. If you want to build for Android, same kind of thing. WebGL, same kind of thing. It's not tough to build for other platforms. If I wanted to, if I did build and I told it, okay, now build for Mac, and I say build, we'll put it in the builds folder, and we'll call it Awesome Sauce. Wait, actually, oh, it wants a folder, Mac. We'll go in there and select. It will then build a Mac version of my game, and you can just hand it to someone with a Mac, and they'll be able to run it. Yeah.
How does it deal, like if I went in there and I built this level that went on forever and whatnot, does it load it all at the same time, or does it render like within a certain number of units of where you are?
That's totally up to you. Because you have very fine control over it, you can say, I only want it to, you know, render this far. And a lot of times what games will do is games will only render what the camera can see. And anything past that or outside of that, it just doesn't render it. In fact, how many of you heard of the game Horizon Zero Dawn? Okay, so there was someone actually posted a great GIF. Let's see, Horizon Zero Dawn camera culling. Oops, camera. Sorry. I think this actually has a good animated GIF. So this is what's happening in the game. This is actually happening in most all games when you're looking around. It is. It's kind of cool. We'll load it here. We'll make it a little bigger.
So the blue is a viewpoint?
Blue is just empty. Yeah, the blue, you know, pyramid going out, that's what the camera sees. And everything else is just loading and unloading what the camera doesn't see, because it's like, why even have that, you know? Why keep track of what's going on in the mountains that you can't see? This happens in most games, and that's just how they work. In some stuff in Unity, you can just turn that on automatically, and it just will do it for you. It goes, oh, that sphere is not even in the camera. I'm not even going to draw it. Because otherwise, the program will do the work to draw it, but since there's no pixels there, it's just a bunch of wasted, you know, processing.
Cameras have a max like distance they can see.
No, not really. I mean, you can set that. You can set like anything past this point I don't want to see, or you know, really whatever you want. So how did this go? Oh yeah, so my thing finished. I have a Mac.app. I accidentally named it Mac instead of Awesome Sauce. But if I copy this to a USB stick and hand it to someone, they can just run it on their Mac, and it would be the exact same thing. And there wouldn't really be any difference.
You wouldn't need anything to play the game, just the file itself.
Just that, yeah, that's it. Yeah, Macs do a good job of packaging the whole thing into just a single file. You know, it's instead of, you know, Windows often has like the exe file and there's DLLs and there's, you know, support folders and all this kind of stuff. Mac, it still has all that, but it's tightly packed up into almost like a zip file, basically. So, why am I telling all of you this? Because it's really easy to get into doing this stuff. Like, Unity's website, if you just go to unity3d.com, they have a section called Learn. You click Learn, and they have tons of tutorials that start from like making whole games to just very specific tutorials about like here's the physics section, and let's say you want to use, you know, you want to know how colliders work, or rigid bodies, which are the things that add physics, right? You can just click on one of these and it will explain what rigid bodies are. And so like this is a
Colliders are
4-minute video that just tells you what colliders are, and that's it. I'll just show you quickly what.
a component that allows the game object they're attached to react to other colliders, provided that one of the game objects has a rigid body component attached. Colliders come in various shapes and types, and are denoted in the scene view by a green outline. They can have the following primitive shapes: a sphere, a capsule, and a box.
Anyway, so it's a 4-minute video, and it just explains what colliders are. They have hundreds of these videos, and in the scripting section, it's all just stuff about C#, about how C# scripting relates to stuff specifically in Unity, like variables and functions, if statements, loops. You know, when you want to translate something, like, you know, change its position or rotate it, it's got stuff about that. It's even got stuff about, you know, like C# object-oriented concepts, like, you know, classes and, you know, interfaces and stuff like this. It's like this. It goes into how that works with Unity itself. And they're all not very long. They're pretty short videos. A lot of them have source code right there in there for you to use. And you can just dive in and pull stuff apart pretty easily. Oh, this has the on mouse down, which is probably what I was typing something wrong on. Like if you want to get something to look at, you want to get one object to like look at or point at something. Like say you have a turret and you want to point it at the player. There's a short little tutorial that says, here's how to get this object pointed at that object, and that's it. And that's all the tutorial covers. It doesn't cover anything else. Doesn't get into any more complexity. It just says, this is how you get this thing to look at that thing, and that's it. It's got stuff about, you know, building a user interface. If you're doing audio, if you're trying to make something animated, and this is just on the Unity site. There's tons of other tutorials out there on YouTube. There's whole courses on just doing this. But the reason that I like it is because, you know, I went into it just knowing just knowing C#. And I wanted to make games. I had no idea how to make games. I had no idea how they worked. I had no idea where to even start. I just knew that I like playing games and I want to make them my own, and I know C#. Where do I go? And I was able to get up and running and making my own games, and I was pretty happy with it. Yeah.
Last time you showed us a 2D game kit.
Yeah.
Which one is your favorite?
I tend to do 2D because it's easy. There's a whole dimension you don't have to think about, you know? But I really enjoy 3D. It's just my problem is I'm not great at like 3D modeling and all that kind of stuff. I have a game that I created. I'll show you. I think I can pull up the video of it.
And I guess it's just true that on the 2D game kit you also can add all kinds of C# code, whatever you want.
Yeah, you can. Yeah, with any of these you can do that, which is really nice. Let's see, I gotta log in here. Sorry, 1 second. Well, I'm not gonna do it right now then. But I have a game that I've been making that's, you know, like a game where you have 4 players running around, and it's like arena brawler type thing, and it's a lot of fun, and it's the first like bigger 3D game that I've made. But it's a lot of work, you know. I've made lots of 2D games for game jams or other stuff. You know, some of it was like a math learning game, but 2D tends to be easier for me.
Yeah. Are there AI components?
Yes. So let me show you remember I talked about the assets, right? You have these packages of assets. One of the Unity's strengths is what's called the asset store. And the asset store is a huge store filled with assets from, like here we have 3D animations and characters and environments. to doing things like machine learning or sound. But then if you keep scrolling down, there's tools like AI, animation, audio, camera. So if you go to AI, oh, sorry. They just updated the asset store, so I'm not as familiar with that interface yet. Scripting, AI, here we go. So these are all assets you can get that have to do with AI, and all aspects of AI, from like the first one here is called A-star pathfinding. How do you get something to go from point A to point B? You've got a level, and it's got to go from here to here. How do you get it there? How does it find its path and go around objects and go around, you know, the level and actually like avoid stuff without just going straight there? And that's what this whole asset is. You have one for doing dialogue systems, a tactical shooter AI. Here's one for doing a neural network.
Are there free ones, Dylan?
Yep, you can sort it. You can say, I only want to see free. And here's all the free stuff. Here's one to do population, smart turret template. So if you want to have a turret that, you know, auto tracks on the player. Here's to make a spawner, another turret script, 2D grid pathfinding, more pathfinding. There's lots of pathfinding stuff on here. Flocking, like if you have a whole bunch of stuff that all needs to like fly together, you know, stuff for doing that. And some of these are awful, and some of them are pretty good. Most of the good stuff makes it on the asset store, but you just have to, you know, read the reviews and see. Some people made this because it worked for them and they just needed it for that game, and it was like really useful. They decided to make it available. It does take some work to get it on the asset store, so it's not just kind of a free-for-all. There is some quality control. But that doesn't mean that once it's up, that it's being continually kept up to date. There's other assets that just do simple things. Like there's one of my favorite ones is called Curved World. Because how many of you played Subway Surfer? Ever played that? Okay, it's a game where you probably played something like it, where it's like it's like one of those on rails type of games where all you're doing is like moving back and forth, like avoiding things and picking things up, like Temple Run. You play Temple Run. So it's that style of game, but the world kind of like curves off in the distance, so you can't like see too far in the distance. And I was trying to think like, how would I make a game like that? And that sounds like a pain in the butt, like to have to like curve all your stuff off into distance. How much does it curve, and like how do you make it like flow over the curve toward you? And like and then I saw this asset and I was like, oh, that's so simple. They just make it a flat world, and it's just this graphic asset you drop in, and the graphic asset makes it so it bends it like a lens away from the viewer. And that's it. I'll show you what it does. It's like, and this is the kind of thing where I would not want to spend time figuring out how to make that. But I'll just play the promo thing for you. So you start with a flat world, and it's literally a slider bar of how curved you want it. Yeah. anyway, so you get the idea. Like, that's a really cool piece of functionality to have in your game. Like, to be able to have it, like, curve away and be, like, a whole curved thing. And, like, you saw, like, you know, that, like, cityscape where it was, like, curving off in the distance. But you don't have to program it like that. You can just program it nice and flat and, you know, and that's easy, a lot easier, especially when you're trying to figure out physics. Like, if you shoot something, does it go curved? Does it go straight? Like, this, you just, like, no, just pretend it's all flat, and then you just add this thing on, and then drag the slider, and it goes, and then you're good, and you're done, you know? Anyway, so, like, that's an example of just one asset you could use. I use an asset all the time that is just for doing smooth transitions. So when I, like, click on a button and I want it to go, like, boom, right? I could write a script, I could write a C# script to, you know, when the button is clicked, change the scale of the button so like it's bigger and then smaller and then bigger and then smaller and then bigger and smaller and like that. Or I could just add in this one C# command, and when you click the button, it goes boom, you know, like that simple. So like I said, there are tons of these in here. Like just the categories alone are huge of types of things you can use. Particle systems, like if you want to do like cool magic effects or water effects or fire or whatever, it's really simple to add things like particle systems to your game. Just to give you an example, like here, we're out a particle system right here, and there we go. It's, you know, it's running, and each of those particles are getting spawned, and you have all of these controls over how you want that to happen. Like, how long should they last? Should they have gravity? Like, let's say we want them to have gravity. Now they have gravity. Let's say you want them to have half gravity. Okay, half gravity. Let's say you want them to change the size as they go over time. We'll turn gravity back off, or turn it really light. So we'll say their size should change from small to big, or you could say I want their size to change. I want their size to start out big, and I want them to get small. And then, as we have, we'll turn gravity back on a little bit. So now you can see they're getting much smaller as they get older. As the particles get older, they get smaller. We can make it so that they change color as they age. So instead of just always being white, they go from white to red. Now they start off as white, but as they get older, they go to red. And I mean, you can change tons of stuff about this, and it's that easy. And you can make it so that, like, when a box disappears, a particle system, you know, happens, and it goes, you know. You can add those pretty easily. The main point is that there's a lot of functionality packed in here, but there's not a lot of C# coding knowledge that's needed to start doing something useful, you know. And there's not a lot of C# coding knowledge needed to just start picking apart functionality that is already built in. You know what I mean? The games that you make, they're not gonna, you know, the games that you see out there, like, you know, GTA 5 and stuff like that, they had hundreds of people working on those games for years. Like GTA 5, I think, was in production for, I think, four or 5 years by like 200 or 300 people. You're not going to compete with that. I'm just telling you. But at the same time, you can get started working on something if you just have some basic C# knowledge. And those tutorials that you'll find on the Unity website allow you to go through and make whole games. Like this tutorial here, the rollerball tutorial, just gets you like a simple basic game. You don't need any extra things. It gives you all the code that you need to write, and it walks you through all the code so you know what's happening. 2D Game Kit is a whole way to make a platformer game without having to write a lot of code, hardly any code at all. I think it actually even has a video here. Let me see if I can find the video that introduced it. They just launched this a couple weeks ago. Yeah, here it is. So I'll play you this video.
Introducing the 2D Game Kit, a free new package that empowers you to create your own 2D platformer game without writing any code. The kit has a ready-made example game, but all the tools, mechanics, and assets are designed as a kit for you to make your own game. Let's take a look at how it works. With a couple of clicks, we can add a blank new scene with our character Ellen ready to go. We can then use the Unity tile map feature to draw out a level design.
That's cool. That's a cool feature.
Next, we can use ready-made game mechanics like opening doors, hitting switches, and placing hazards to build out our game, and get creative with settings to make them behave the way that we want. Everything is done visually using the Unity editor with draggable gizmos in the scene and adjustable settings in the inspector. We even have a full written manual to help you learn how to use each part of the kit. So go pick up the 2D Game Kit for free on the Unity Asset Store right now using the links below. And if you've got feedback for us, please let us know on the Unity forum. Thanks for watching.
So obviously that game has a lot of art built in too. You know, that I mean, if you want to totally make it your own, you have to make your own art. But the functionality is all built into that, and you can just download it. That's another, it's just an asset you download. And that's an example. That's a very complete asset. That's not just like, oh, let's make the turret point in the right direction, or oh, let's have some cool rocks or a cool sci-fi city. Let's build the whole functionality for building an entire game. Just import that into our project. Anyway, so I just, you know, this is something that you can get started with fairly easily with not a lot of C# knowledge under your belt, or even if you're just beginning. The reason I suggest this, aside from it just, you know, it uses C#, and I know most of you are learning C#, is that one of the best ways to really have something stick with you is having your own personal project that you're invested in, that you like and want to be working on. Like, my personal experience with that is like, I have learned so much stuff for my own projects that stuck with me way more than like when I went through and was just like crunch learning something, right? And if you're, you know, doing that thing where you're like, you know, pounding through and you're like learning a whole ton of stuff, that's useful because if you're then going to immediately go use it. But if you're not going to immediately go use it, or you don't have something you're immediately applying it to in your own life right then, it can be harder for that to really stick and sink in and become like your own knowledge. You know what I mean? And this is a really easy way for those kind of things to, like, you can have a project that you really like and are really having fun with and have it be your own knowledge. You know, stuff that you're learning here can then, you actually have a project of your own that it's like, yeah, this is, you know, completely your own project. Yeah.
I was going to say, too, is that this is also available for augmented reality as well. Right?
Yes, that's right. And the thing is, like, it actually comes with a tool called Vuforia. And Vuforia is a whole system for doing augmented reality. And you can just do it with your phone. Like, if you have your phone, that's a way to get started with it. Let me see if I can find Vuforia. So this is a whole system for doing augmented reality where you can have, like, you know, like you point your phone at something and you see it, or you want to place stuff in augmented reality. You know what I mean when I say augmented reality? Like when you have like stuff that's like overlaid over like a camera image, or I mean, it can be stuff like if you have HoloLens where you're wearing like sunglass type things and it's like projecting things in the world. But this more simple version is like you have your phone and your camera's looking at something and it's like overlaid on the camera. It's actually built into my Android camera now. Like I can, like without me doing it, I can say, oh, I want like Star Wars stuff. And I can like drop a stormtrooper standing right here and like take a photo. It's like, it's pretty funny. But this actually comes built into Unity. Like you can just go right in here and you know, it's a menu item right there for Vuforia to like add stuff in. Now, of course, there's, you need to read the documentation and the tutorials on how to do that. But it's not like you have to go download special stuff. It's built right in for you to be able to get started with that and being able to, target your phone and that kind of thing. It's pretty cool. I would do a demo right now, but unfortunately, it does take a little bit to build it for the phone, and it's more time than we have. Anything else? Does anybody have any questions? I'm happy to stick around, and if you have any questions that you think of, feel free to ask. We have a meetup here every third Thursday. That's actually hosted by Tech Academy, and we have pizza and so forth. And so if you want to learn more about Unity or just kind of see what other people are making with it, you're totally welcome to come. We also, Portland Indie Game Squad, which is a huge community of independent game developers in Portland. Very open community. We actually have an event tonight at the Lucky Lab Brew Pub in Northwest Portland, where it's just a social event. Everybody just comes, and people are working on games come, and they've got stuff they're working on, just talk about games. You do not have to be like a game developer to like join in and have a good conversation with these people. It's also not just programming, it's artists and sound designers and composers and that kind of thing too. So you're totally welcome to join. I think it starts at 7, but it's a pretty open event.
All right.
Yeah.
Great. Well,
all right.
Thanks for coming, Dylan.
Yeah, absolutely. Yeah.
And I would recommend checking out Unity PDX every Thursday or the third Thursday of the month. It's a good opportunity for you to, like Dylan said, sink your teeth into something you're actually learning. If you have something that you're learning C#, why not have a little fun with it? It's not just games. It could be augmented reality. You could build something that you could use on your phone, and it just gives that extra step and something to kind of drive why you're learning C#.
We have a number of people who've been using Unity, like he said, not for games, but for other purposes, like either architecture, or one person took a family tree and made it so that it would read in the family tree data and turn it into like a neighborhood street where it was just this road you could walk down, and each house was a person on the family tree, and you can go inside the house and it would have like photos on the walls and like little plaques with the information about the person, and it's just reading that right in from a family tree file, but turning it into like a 3D walkable world. That's an example where it's like, it has nothing to do with games, Anyway, it's cool stuff.
Possibilities are endless.
Yeah.
Again, thank you.
Yeah, thank you. Yeah.
And feel free to come and ask some questions.
Yeah, I'm totally happy to answer any questions you have.
Yeah, I was looking at this a little while back.